Hi, for our sixth session today, we've decided to go shopping. We're planning to go to Granth bookstore and we plan to buy some books and CDs. I'm carrying 1500 rupees with me and I plan to buy books and CDs utilizing this money. When I reach Granth and I check the prices, I find that if I buy 7 books and 4 CDs, then I utilize the entire money that I have, which is rupees 1500. So when I buy 7 books and 4 CDs, the entire money is used up. However, if I interchange the quantity, which means if I buy 4 books and 7 CDs, I fall short by 300 rupees. I repeat, if I buy 4 books and 7 CDs, I fall short by 300 rupees. The question now is not about the price for a book or a CD. The question is, if I want to buy an equal number of books and CDs using the money that I have, then what is the maximum possible such number that I can buy? I repeat, I want to buy the same quantity, same number of books and CDs utilizing the 1500 rupees that I have. Hence, what is the largest possible number of this type that I can buy? We'll go through the concepts and then at the end of it, we'll look at the solution to this problem. We're going to go through the topic of linear equations today. Now, when we say linear equations, what do we really mean, or what is the general form of a linear equation? The term linear equation refers to the power of the variable, and when it is a linear equation, it means that the maximum power that the variable can take is 1. So let's look at a general form of a linear equation. The general form of a linear equation is ax plus by plus c is equal to 0. Now when we look at the variables x and y here, we can see that the power of these variables is only 1. And when the maximum power is 1, or when the power is 1, such an equation is called as a linear equation. Now there are 2 types of linear equations that we can look at, or which we use very commonly to solve problems. The first is what is known as a simple equation. Now when we say simple equation, what we mean is such an equation will have only one variable, either of these two, x or y, but only one variable, and the power is 1. This power 1 is also very commonly referred to as an equation of degree 1. So when an equation of degree 1 has only one variable, that kind of an equation is called as a simple equation. However, when such equations exist with more than one variables, for example here we have an equation with 2 variables, such equations are known as simultaneous equations. I repeat, provided the degree is 1. So when the degree, which means the maximum power of the variable, is 1, it's called as a linear equation. And within linear equation, we are talking about 2 types. One where there is only one variable, such an equation is called as a simple equation. And if there is more than one variable, then such an equation or such equations would be called as simultaneous equations. While we are dealing with this topic of equations, in any entrance exam, it is very rarely, or actually it will never be asked in a manner where the equation is given and then you are asked the value of the variable. What will happen in these entrance exams, you will be given problems in a word form or in a statement form, and we need to convert this problem given to us in a statement form into the equations and then solve them. While we are formulating these equations through the statements, there are a few points that we always should remember, and if we remember these points and incorporate these points into formulating the equations, our solving process and hence calculating whatever is asked becomes simpler. Let's look at the first point. The first point is about selection of the variable. So let's go back to the example that we had taken as part of the introduction. I was going to Granth bookstore and there I find that if I buy 7 books and 4 CDs, then the total cost for these two put together would be 1500 rupees. Now whenever we ask a question or whenever we give this statement, 7 books and 4 CDs together cost rupees 1500. What would be the equation for this statement? The most common response that we would get is 7x plus 4y is equal to 1500. Is this wrong? No, this is not at all wrong. This is absolutely right. But out of our experience, we can say that instead of using x and y, if we use some other variable, our entire solution will become simpler. Now, why do we always go on to x and y? We go on to x and y because that is what we've been used to since our school days. Whenever we solved a question on equations in our school days, we would always think of the first variable being x, the second variable being y, the third variable being z, and hopefully we didn't need more than that. But here what I want you to understand is that why do we necessarily need to start with x and y? Why can't we write the equation as 7b plus 4c is equal to 1500? Why B and C? Because I am buying books and CDs. A lot of you would wonder, what's the big deal? Why are we making a big issue out of it? Well, the big deal is that in an entrance exam, when we find the value of B, we know that is for a book. When we find the value for C, we know that is for a CD. If I am finding the value of X or Y, I may need to go back and check what did I take X as. There is a possibility of an error creeping in here. So if you want to avoid this possibility of an error, the simplest way of doing this is use the first variable, use the first alphabet of the word. For example, book, we can use B as the variable. For CD, we can use C as the variable. So formulating the equation becomes extremely simple when you use the variable as the first letter of the word that is given to you. So our first point is about choosing the variable correctly or properly so as to avoid a mistake later. Let's move on to our second point. Suppose this is the first statement given to us, which is 7 books and 4 CDs put together cost rupees 1500. If I go back to the introduction example, we had reversed the numbers. So we said 4 books and 7 CDs put together, and we had said that I fell short by 300 rupees, which means if I have to buy 4 books and 7 CDs, I will need 1800 rupees. Now the question is, how do we solve this? And when I look at these two, luckily both the equations involve the same numbers, 7 and 4. But let's look at another example. Suppose we had an example where we said 2 books and let's say 7 CDs cost rupees 1200. These numbers right now are irrelevant. And suppose we say 3 books and 11 CDs put together, suppose they cost rupees 1800, whatever be the cost. Now if we want to solve these two equations, and whenever we ask how do we move on, the standard answer is multiply this by 3 and multiply this by 2. This equation by 3 and this equation by 2, so that the coefficient corresponding to B will become 6 in each case. Then we can move on and solve the equations. But my question is, how did you decide to multiply this equation by 3 and this by 2? Why not this equation by 11 and why not this equation by 7? When this question is asked, the standard response is because it is simpler to calculate using 3 and 2. My question now is, yes, it is simpler to calculate using 3 and 2, but what if the question asked is the value of B? By multiplying by 3 and 2, what are we actually doing? We are eliminating the variable B. And if we eliminate the variable B, then our solution would first involve calculating the value of C and then substituting C in the given equation and then calculating the value of B. Once again, why do we do this? Because this is what we've been used to since our school days. Always check which is simpler to calculate and do that. Nothing wrong in it. Why did it work in school? It worked in school because invariably in our school days, we would be asked the value of both B and C, and hence it didn't really matter which one we calculated first. But in an entrance exam, very often you will be asked the value of only one of these two variables. And if that is so, then use your judgment, check what is asked and accordingly eliminate. So if B is asked, then I will eliminate C, which means I will multiply this by 11, this by 7 and directly calculate B. However, if C is asked, then I will eliminate B, which means I multiply by 3 and 2 and eliminate B and directly calculate C. So the second important point that I am talking about is check what is asked and eliminate accordingly. Don't just blindly do it based on what is simpler. So we've gone through 2 points till now. Use your variables properly, which means preferably use the first alphabet of the word and don't blindly just go on to X and Y. And the second point that we've looked at is check what is asked and eliminate accordingly. If C is asked, eliminate B. If B is asked, eliminate C. This will actually tell you what to multiply each equation by and hence calculate. Let's move on to the third point. In both the examples or both the points that we took, we use two variables B and C. But is it always necessary to use two variables B and C or two variables, whichever those two may be? It's not always necessary. It depends on the example. So let's look at another example. Suppose I have a bag of coins. This bag consists of only 25 paise and 50 paise coins. The total number of coins in the bag is 50. So I have a bag consisting of only 25 paise coins and 50 paise coins, and the total number of coins is 50, and the total value of all these coins put together is rupees 10. Now if I want to solve this example, it is possible to solve this example using two variables. The two variables that I would now consider would be T for 25 paise coins and F for 50 paise coins. And now if I write down two equations, then my first equation would be the number of 25 paise coins plus the number of 50 paise coins is 50, and the total worth of the 25 paise coins and the total worth of the 50 paise coins is 10 rupees, which means 1000 paise. So I now have two equations and I can solve them simultaneously. Depending on what is asked, I will decide whether to multiply the first equation by 25 or 50 and solve it accordingly. However, this is an ideal example to prove the point that if it is possible, use only one variable. Why? If you have an equation in only one variable, it is obviously faster to solve that equation with only one variable. So my solution will depend on what is asked. Let's assume for the time being the number of 25 paise coins is asked. That means my variable would be T. Automatically the number of 50 paise coins will be 50 minus T, because if there are T coins which are 25 paise coins and the total number of coins is 50, the number of 50 paise coins is 50 minus T. So now my equation will be 25T plus 50 into 50 minus T is equal to 1000, and this is an equation in only one variable. Very simple to solve an equation in only one variable, and when we solve this equation we will directly get the value of T, which is the number of 25 paise coins, which was the question asked. So the third point is about use only one variable if possible, because it is simpler and faster to solve questions involving only one variables. To summarize these 3 points that we've gone through, the first point was about using variables properly, preferably the first alphabet of the word. Second was check what is asked and eliminate accordingly, which will tell you what to multiply each equation by. And the third point was about use only one variable if possible, because it is simpler and faster to solve questions using only one variable. These are 3 extremely important points when we formulate equations. It will save time and it will reduce the possibility of an error in the question. We have looked at different types of simultaneous equations, and when we solve the simultaneous equations to calculate the value of the variable either x or y, these values would be called as the roots of the equation. So the solution of an equation is called as the root of the equation. We'll now look at a few examples where the question talks about only integral roots. So let's talk about this example. 2x plus y is equal to 10. Now if it is mentioned that the value of x and y can only be integers, then one possibility is that x can be equal to 4 and y can be equal to 2. Because the moment you put x equal to 4, you get 8 plus 2 equal to 10. So 4 comma 2 for x comma y would satisfy such an equation. And now that we know, or we are told in a problem, that the roots can only be integers, how do we move on and look at other possibilities? Now the other possibilities would depend on the coefficient of x and y. We notice that the coefficient of x here is 2, and hence it would actually impact the value of y, which means the value of y would now keep changing in steps of 2. The coefficient for y is 1, which means the value of x would keep changing in steps of 1. And if there is a plus sign in between, then these changes would be having an opposite effect. What does it mean? If x increases by 1, then y would reduce by 2. So let's check this out. If x increases by 1, which means if x becomes 5, y should reduce by 2, which means it should become 0. If we check, does this satisfy the given equation? When you put x equal to 5, you get 10 plus 0 equal to 10. It very much satisfies. If x changes to 6, which means it is going one step beyond, the change of x can only be in steps of 1. If x becomes 6, then y should reduce by 2 from this value, which means y would become minus 2. Once again, if we check whether these values of x and y satisfy the given equation, yes, they will satisfy. So when the problem talks about integral roots, then we can start with one particular solution which is very easy to figure out, and then we can just keep checking x has to change in what steps and y has to change in what steps, and accordingly find out the value of the integral roots. This example, you will notice that we have intentionally taken a minus sign in between to explain what happens when instead of a plus sign you have a minus sign. Once again, we can check one of the possible solutions would be x is equal to 3 and y is equal to 1, because 9 minus 1 would give us 8. Coefficient of x is 3, which means y changes in steps of 3. Coefficient of y is 1, which means x changes in steps of 1. Since there is a minus sign in between, the two changes would be the same, which means if x increases by 1, y would increase by 3. So if we change x to 4, that means 3 into 4 would become 12. Y has to increase by 3, which means y would become 4. And now if we substitute x equal to 4 and y equal to 4, we notice that it satisfies. We can move on in this manner. Suppose from this step we go back, which means if x reduces by 1 and hence it becomes 2, y has to reduce by 3 and hence it would become minus 2. So x equal to 2, 3 into 6 would be 2, minus of minus 2, which would satisfy the given equation. So this is an interesting aspect that we can use whenever we are solving problems where it is mentioned that the roots or the solutions have to be integer values. Building on this, let's try and solve such an example. So we have an equation 2x minus 5y is equal to 9. So if we try to write down a possible solution, x equal to 7 and y equal to 1 is a possible solution. Suppose the question talks about only positive integral solutions, which means x and y have to be positive integers. And it is also mentioned that x is less than or equal to 1000. The largest value that x can take is 1000. So the question is, how many such integral solutions exist? We have our first integral solution as 7 and 1. And why is this the first? Because the question talks about positive integral solutions. Since the coefficient of x is 2, y would change in steps of 2. Since the coefficient of y is 5, x would change in steps of 5. Now the question is, how many such positive integral solutions exist? Which means there is a restriction placed on x. The largest possible value of x is going to be 1000. The first value of x is 7. The next value of x going beyond would be an increment of 5, which is 12. And then the next value of x would be 17, and so on. So the question is actually 7 plus 5n is less than or equal to 1000. Which means that if you keep increasing x from 7 in steps of 5, what is the largest possible value that n can take, or how many values of n can exist such that this is satisfied? Now if you actually calculate this, n can take any value from 0 to 198. One of the most common errors here, what students would do is they would find n as 198 and it would still satisfy this kind of an inequation, and hence they would say that the number of possible solutions would be 198. The correct answer is 199 because n can also be 0. Hence for this kind of a problem, 199 positive integral solutions would exist, subject to the fact that x is less than or equal to 1000. This is how you can solve questions based on integral roots or integral solutions.